Hello, everyone. We are back with yet another session of Expert Insights Live, and we've got Andy with us. Andy McMahon is one of our authors who's written an exceptional book for the second time, Machine Learning Engineering with Python. Andy, why not you take it ahead and you introduce yourself? I wouldn't be the right person to do that.
Yeah, okay. Well, you think I am Tushar? That's dangerous. Hi, everyone. So I'm Andy McMahon. My role just now is I am head of MLOps at NatWest Group. So I own the MLOps strategy for one of the leading financial services organizations in the UK. I've worked through my career as a data scientist, as a ML engineer in the trenches. I've worked kind of on the strategy side, like now, everything to do with MLOps, ML engineering, and data science, I'm absolutely fascinated by. And yeah, as Tushar mentioned, I am now an aspiring / published author. So that's been an exciting new part to my journey over the past few years. So I'm glad to be here.
Quite modest, Andy. So before we get started with the session, if people can hear us, just so that we are not talking to ourselves, if you could just drop in a comment and mention that you can hear us, that would be great. We'll just wait for a minute or so before we start with the session.
Let's hope we have at least one.
At least one person, yeah.
At least one. Maybe two, one each. That would be good.
Yes. So I've been notified that there are 5 people, at least that's what the system says over here. But I'm not really sure if there are any people. Yeah, thanks, Monica. So at least there's one person confirming that they can see us. So there are more.
Hello, Monica.
Hi, Monica. Hi, Eunice. Hello, LinkedIn user. Sorry, your name does not flash up for some reason. Perfect. We've got a lot of people. They can hear us loud and clear.
Perfect.
Great. Now that we know that we're not talking to ourselves, just to notify everyone, there is a giveaway going on, as you can see in the bottom ticker. A couple of people hold a chance to win Andy's brand new book, Machine Learning with Python Engineering. Just comment with #packed, and we'll have a raffle a couple of times during the session, once in between and once towards the end. And it will be completely transparent. I'll share my screen and we'll do the raffle. So whoever's the winner, you'll get to see it yourself. And if you have any queries for Andy during the session, please post it in the comments. I'll flash it up on screen just like this. And Andy will take it over and he'll answer the queries for you. So because there aren't any queries here at this point in time, Andy, I have quite a few of them. Why not start with, Andy, how do you become or start a career in machine learning engineering? How would someone go about doing that?
Yep. So I'll give a brief overview of how I did it and then talk about how I see the landscape's evolved, which is really positive now. So I started as a sort of data scientist in a scrappy startup and just building what I could. And I realized very quickly that I wasn't going to be allowed to just build some nice algorithms in a notebook. I had to, in the organization I was in, build these into services and connect them to applications. So we had a web platform we were selling to customers, and the ML was to power certain services within that. So very quickly I learned, at the time it wasn't probably called MLOps or ML engineering, but I quickly learned that, you had to wrap models in a pipeline and you had to also wrap them in services. You had to make things that interacted with other systems. So I became an ML engineer through the sort of vocational route where you learn it the hard way just by doing. And that then, as the field matured, became more of an obvious label to label myself. Nowadays, there are really interesting opportunities. I know we hire for junior roles in ML engineering. You have lots of courses online, both free and paid, across a variety of different platforms. There's even university courses now that talk about MLOps and ML engineering. So the opportunities have really grown substantially to retrain and move into that space. So I think the key thing, and it's a real ethos that I always have, and it's hopefully comes through in my book, is the key is to build something. The key is to get building. So no matter what your current role, whether you're a data analyst or even a product manager or whatever. If you want to get into this space, the key is to start building stuff, and you can do that with all the resources that are out there. Hopefully my book is one of them, but you can also go and find so much stuff online. Just start building, do a pull request, learn how to code, and just start building those solutions. And before you know it, if you're building something valuable that solves a problem, you can call yourself an ML engineer. So that's what I would say. And I'd say it's far easier now than it used to be. Even though the field's moving so fast, it's far easier to make that initial step.
So Andy, what's basically the difference between data engineer, MLOps engineer, ML engineer, and are there any overlaps?
Yeah, so I think this is a brilliant question. To me, I always try and bring things down to the simplest thing that captures the essence, but it doesn't capture everything about the role. So for me, a data engineer is about building robust solutions that take data from A to B with transformation in the middle, potentially, or after or before some of those steps. So essentially, you're building pipelines that take data from a source to a target, potentially transforming it in the middle. That's a very slimmed down version of what a data engineer does. There's so much to it, but that's the core essence, right? An ML engineer will do a similar thing, take data from A to B, but the transformations they do are often ones that use algorithms from machine learning. So if you're doing the same idea of pipelines, moving data from A to B, from source to target, but you're also applying machine learning algorithms, you're doing ML engineering. And an MLOps engineer, which is a bit of a newer title, has a lot of overlap, and they all have overlap with each other, right? So the key word is engineer here. So you're applying software engineering principles, you're applying good practices that we've learned from the world of software, but applying it to this new world of data. You're building robust, reliable, repeatable ways of doing things as well. An ML ops engineer, to me, although it can differ for some people, is really when you're trying to build the apparatus to help the ML engineer do their work, or even the data engineer in some sense. But you're trying to help build the platforms, the solutions, the best practices that enable the actual building of, say, business or organization facing solutions faster or more reliably. So it could be that you're hooking up and making monitoring solutions, or you're working with vendors to use their monitoring solution and adding certain pieces. That might be what an ML ops engineer does. An ML engineer would then use those monitoring solutions in their products that they're building to monitor their own pipelines. And the data engineer similarly would have maybe their own monitoring solutions, but looking at slightly different things. So there is a lot of overlap, and I think it's that concept of engineering, building, making things real that unites them. The differences are just ones of kind of the areas of focus. And you often see that in a particular project, if you have a really good mixed team around you, people will be doing little bits of everything. And I think that for me, ML ops is really a practice that everyone should be involved in, just the way DevOps was for software. So machine learning operations, it's about making machine learning models go live and into products. And that's just a set of practices that envelops everything. And then these different facets sort of are covered within it.
Right. So just a reminder for everyone, if you have any queries, please post it in the chat, and Andy will be more than happy to answer it for you. I can see there's one query about logistics. When yes, the video will be available on YouTube. Well, we don't plan to remove any videos, so it will still be there. Even if you missed this live session, you can watch the recording later. So yeah, Andy, while we're waiting for questions to come in, you mentioned an important aspect of MLOps and ML engineering, that is building a pipeline, a machine learning pipeline per se. Now, my follow-up question to that would be, what is the most difficult part of building a machine learning pipeline?
I think there's maybe two aspects to this. There's a technical aspect, just technically what's the most complex. There's also a kind of wider, more strategic question. And I think the wider, more strategic question is making sure that you're building the right pipeline for the job. So sometimes you can be asked to build certain machine learning solutions because it's a novelty or a nice to have, or it's maybe solving a business problem, but it's not the really core business problem. So the question is really, how are you building in processes and interacting with people to make sure you build something that actually solves the business problem? And in the book, there's 2 worked examples at the end. There's kind of examples I give from my experience throughout to try and help give flavors of this, where you might be building a pipeline and you might make it the most amazing, beautiful pipeline ever, but if the results don't actually impact the core function you're trying to help, then you've not built the right pipeline. So that's a more wider strategic one. I think that's hard to get right. From a technical aspect, it's a bit of a cop-out, but I think they can all of the aspects can have their challenges. So whether it's the sourcing of the data and working with the data engineers to make sure you've transformed the features appropriately, that's hard because you're often working across the boundaries of a team. And you're often trying to bridge that gap and translate what the data engineers are saying to what the ML engineers are saying and make sure it all matches up. And you're trying to maintain data integrity across that divide. I think once you're in the realm of just building the core pipeline, there's now so many tools and so many things available to help you that could often be quite a streamlined process. That's the sort of bread and butter of an ML engineer. And then at the other end, you get a challenge because you then have the last mile integration. So you have to send the data where you've ran some ML inference. You have to send that result somewhere. And that can often be very challenging because, again, you're bridging a gap to other systems. So whether that's because you've built an API that someone has to hit, you have to make sure your API documentation is really good, the API contract makes sense, or whether you are doing a more direct injection of data into a lake or a store or a warehouse that stores data. You have to do a lot to maintain that data integrity and metadata to make sure that that's all very clearly managed. And as well, you have the final piece that I think can be difficult is the monitoring aspect. So monitoring and validation, I see we've got a question about sort of validation as well, but the evaluation of ML models has always been a challenge. And now in the generative AI era, it's even harder. But I think working out how you're going to monitor these solutions post-production is absolutely critical. I've often said that if you think you're not doing MLOps, you're just doing it badly. Because often what it means is you're maybe deploying without monitoring. And that means that you're just almost kind of blind as to whether performance is dipping or going up. But even if you're thinking about it and you build monitoring in, building a good monitoring solution can be quite difficult because you really need to be clear on what's the actual metric that's important. What are the parameters or the kind of the bounds of that metric that are good for triggering alerts or for intervening? And that can often be a really long sort of complex conversation with business because you impact processes, right? If you have something that's really sensitive, you'll trigger lots of alerts all the time and your operational team will burn out. If you don't catch the important things, then you maybe miss some really important cases. So I think monitoring is particularly hard as well. So that kind of first mile integration, last mile integration, and monitoring, I think, are the 3 main technical challenges I see. The sort of central bit of building a pipeline is often more bread and butter and quite streamlined, I think.
I think Krishna's query is bang on a follow-up to what you just spoke about. Performance metrics and all of that. So Krishna inquires what accuracy is considered good in industries and at what accuracy does one deploy it? About 80%?
Yep. Thanks for the question, Krishna. So I think the metrics you're going to track are so dependent on your use case that it's often quite dangerous to say deploy at accuracy 80% or precision, whatever percent, or recall or F1 score or whatever the metric is. It really has to be a collaboration between you as the person or team building the solution and your key stakeholders. So either your end consumers, your partners, your colleagues, whoever's going to be using the solution to drive decision making. You really need to work out from that what it is you're going after. It could be that maybe in a certain solution, you don't need a high accuracy. You just need some insight that gives some direction of travel. So it could be that 40%, 50% gives you some indication, but as long as that's made aware to the user, then that's fine. It could be in cases though, like financial services, catching fraud or something, or where you're maybe in a healthcare setting, that it might not be accuracy, but it could be precision, for example, or sensitivity should be really high. And that kind of just has to be determined on a case-by-case basis and agreed between all the parties. So I would say, Krishna, it's if you ever see anyone suggesting a sort of rule of thumb like that, probably it's definitely double check it and take it with a large pinch of salt because you might make some hard decisions with that. So I think always map it to your use case, and always think very hard about what success means for your solution. So I'm not going to give you a rule of thumb, because I think rules of thumb like that are probably bad for metrics, but definitely explore it. It's a good question.
Thanks for that, Andy. There are quite a lot of questions coming in now, which is amazing. Thanks everyone for that. Vinay on YouTube inquires, and which book you recommend for automation for machine learning?
Well, obviously my book, we talk a lot about automation, auto ML, we talk about quite a bit. We talk about optimizing hyperparameters in an automatic way, which is a big part of the machine learning sort of solution build process. There are a few other books. So there's Engineering MLOps by Manuel Raj from Pact as well. There's a few other specific titles on auto ML specifically. I think all of these are really good. But we do cover a lot in this book. So a big part is about chapter 3 is called From Model to Model Factory. And in that, it's all about how you start building in automated or repeatable solutions and processes that help you take new data, take results of how your model's performing, and then automatically generate new models. So there's a lot in there about it. But there's tons of titles out there, Vinay, but I would think I would start with some of those.
Perfect. Jorge inquires on LinkedIn, what do you need to start infrastructure and software, please, for machine learning engineering, I'm guessing?
Okay. So if you're starting to learn sort of yourself, and that's what you mean, you just need a laptop and an internet connection, and you can go for it with all these online courses I mentioned. If you mean more kind of in your organization or starting to actually build and deploy things, I think what you really need is, first of all, the first principle I always say is that tools are sort of secondary. The specifics of the tools. The key is getting a systems understanding of what you're trying to do. I think, Jorge, the key thing is trying to understand, for what I'm trying to build, what do I need to do in terms of, is it actually mostly going to be batch processing and batch systems? Because I only need to run inference likely for the majority of use cases I see in the future, for at least a while, I only need to run something once a day. In which case, it could be very, very different in terms of if I have to have sub millisecond latency or very millisecond latency on a very fast acting real time system. So that's the first sort of question, is what's the system I'm trying to build going to have to do? What's the sort of non-functional requirements for the whole platform, if you like? And then from that, you start thinking about things like, what volumes of data am I going to have access to within the world I'm in? So if you're in a sort of scrappy startup that doesn't have much data, but you have some innovative algorithms, you might just be working with, relational databases, SQL, etc., or whatever solution is available from the cloud providers. I'd always say starting with the cloud, very good. A lot of them have free tiers where you can start experimenting with all the tools, and it's very good to just spin up infrastructure and tear it down. But yeah, that sort of data volume question really helps you understand as well. And then based on that, depending on specific use cases, you can then start building. So I would always say that don't make your life harder than it has to be. So I mentioned the clouds. So AWS, for example, and I talk a lot about AWS in the book, but obviously GCP, Azure, other clouds provide this. They have a lot of really good platform as a service solutions where you can just push a few buttons, and from that you provision a lot of what you need. So AWS SageMaker is a great example. If you're at that kind of earlier stage, that just provisions a lot for you. In the book, I go a bit lower level. I don't go all the way down to, doing things like Terraform to spin up infrastructure and spin it down, although that's definitely part of ML engineering. I speak a lot about a kind of a level below PaaS, but a level above what I was talking about there, where you can do things like, if you know you're going to run containerized applications, use Elastic Container Service on AWS along with Kubernetes. If you want to run your ML pipelines and use a kind of standard framework using tools like ZenML or Kubeflow, they give you a lot of real power so that you can just add some decorators, add some simple code to your existing code base, and that sort of supercharges it. So you can build the basic ML pipeline, and then you can add some decorators, add some extra bits, and that then takes it to something that through a few commands you can deploy. There's maybe some more work required to hook that with certain infrastructure, but you fundamentally always just need a compute engine, you need a data storage engine, and you need an application layer. So the compute engine can be anything from base virtual machines. It could be your laptop, but it could be various base virtual machines in the cloud, EC2, etc. Or it could be something like I mentioned, Elastic Container Service, etc. Your data storage could be, I mentioned, relational databases, could be data lakes like AWS S3, or it could be a lakehouse, could be what Databricks offer, etc. And then your application layer could just be you're exposing as an API, could just be that you're actually spitting out data to somewhere else in a data lake on your data layer, or it could be you actually want to build a dashboard. So maybe you're looking at something like, Tableau or one of the other tools like that. But I think that systems mapping, I sort of said at the beginning, is the most important part, Jorge. Sorry, that was a long answer, but I think there was a lot to cover in that one. It was a good question.
Not at all, Andy. I'm glad you got a way of help to them. There is a question from LinkedIn user. For some reason, the name's not appearing. Why machine learning engineering is only with Python, but not with any other programming languages? Just wanted to know.
Yeah, good question. So I would say that machine learning engineering is definitely done with other languages. There's a lot now going on, kind of the JavaScript, TypeScript world. There's now Rust is an up-and-coming language. There was a lot with Scala before, and kind of still there. So there's a variety. There's a lot in the Java ecosystem still, I think, as well. So there are definitely other languages used in machine learning engineering. The reasons I focused on Python for the book were, one, that's where I have most expertise and kind of confidence in. I don't think anyone would like my C++ skills or my Scala skills from before, but that's the one I'm most confident in. But the real core reason was Python is still the lingua franca of data. So it's basically the language that is spoken most across the globe. And I mentioned this in the book, it's still the #1 ranking language across so many metrics. It's so easy to use, yet so powerful. It has such an active community. And it is definitely the most used language for machine learning in the world. So I think if you can do machine learning engineering in Python, you can definitely map that to other languages, because it's more about the concepts, because Python is a bit of an easier language to use. So you won't be bogged down with just learning lots of complex syntax. And Python as well is still the most employable language, I think, if you're in the data space. It's definitely the place to be. So that's kind of why. But yeah, definitely we'll be seeing lots of other books on ML engineering in different languages through the years, I think.
Thanks a lot for that. Speaking of programming languages, any project using the new Mojo programming language? Is that Mojo or Mojo?
Mojo. Yeah.
It is Mojo. Okay.
Mojo in Spanish. Yeah, I think Mojo. Yeah, is. I'm really excited by Mojo. Actually, good question, Jorge. I've not done anything with it yet, but I'm on the sort of the Discord or the Slack, whichever the one they're using, and sort of seeing a lot of interesting stuff coming from it. So for anyone who doesn't know, Mojo is the sort of superset language that's came out for Python, the same way TypeScript is for JavaScript. So the idea is it can extend a lot of Python's functionality and make it a bit more performant, a bit more optimized, but also a bit more generic. So I know I'm really excited by Mojo, and I think machine learning engineering, machine learning with Mojo will become a far more prominent thing. And I think it will leverage a lot of the existing ground that's been broken by Python, because it is that superset language. So I'm excited by Mojo, but I haven't done anything with it. I'd be really keen to hear if anyone has and what they sort of think. So ping me on LinkedIn if you have, or in the chat.
Yeah. Or join Discord. You can share your experience.
Absolutely.
So anyone who is not aware, and if you're watching us live, we've got a Discord where we've got about 5,080 members as of today. And there are quite a lot of different interests that all of us share. And Andy keeps helping a lot of the readers answer their questions of how to navigate through the book if they are stuck anywhere, troubleshooting, or if they have any other queries about the projects that they are working on. And there are other authors and there are experts who help a lot of people as well. It is a fun space. It's a good learning space. So in case you're wondering where the link to join is, you can just head over to my LinkedIn profile, and right on top in the bio, there is something called Join Machine Learning and AI Community. And you can just, it's a hyperlink. You can just click on that and join us over there. So moving on to the next question, Vinay from earlier, on YouTube inquires which book you recommend for machine learning for automation. I think you answered this
We did
already.
that one. Yeah, we did that
Yeah,
one.
yeah. Okay, so moving on, Prince on LinkedIn inquires, what are the key monitoring metrics teams can use to get started?
Hi, first of all, hi Prince. It's great to have you here. So Prince was one of the technical reviewers for my book. So
Oh,
thanks for joining, Prince. Excellent. Give him a follow, everyone. He provides excellent content. Key monitoring metrics. Yeah, so any of the sort of classic metrics for your ML algorithms. So if it's classification, your precision, accuracy, recall, F1 score, things like that. If it's regression, your mean percentage error, root mean squared error, etc. I think the metrics are all the classic ones that you would use when building a machine learning algorithm. So whenever you learn everyone about machine learning and you get taught train, test, validate, split, and here are the metrics. Those are the sort of core metrics upon which you build a monitoring solution. There can be other ones, when you start looking at drift. So you can start looking at the distribution of your data. There's different divergence scores you can use, KL divergence, etc. And you start looking at how those distributions are shifting through time, and that adds to it. The big sort of mindset shift, though, I think, and I've definitely seen this in a lot of projects, is when you're building your initial algorithm or a data scientist building the initial solution, it's often with a static slice of data. So it's often you take a big set of data, and it might be huge, might be small, but the point is it's time bound. Even if it's time series, it's still a set of data. And then what you do is you calculate your metric on it, and we often get some statistic that says, right, this looks performant. The challenge when it gets to monitoring is everything moves to a time-based domain, even if it's a batch system. So you can still, if you run a daily batch, like the example I mentioned earlier, calculate your accuracy, your precision, your recall, your root mean squared error, whatever it is. You still calculate that for that day and say it's above or below a certain threshold they've set. But you then also have to start thinking how that's tracking through time, even if you're doing this big batch every day, because the idea is that you might get concept drift. You may get drift in the relationship between the core features you're using from the data and your target. And that might only manifest through time. So it might be that you see today it performs, then tomorrow it doesn't, and then the day after it maybe doesn't again, and they're sort of up and down. But if you've plotted that through time and ran some algorithm to check the trend, you might see that overall it's declining. And that could be because something's changed in the world. A good but very sharp and abrupt example was obviously the COVID pandemic. That changed a lot about how many data sets worked and performed. Some of the effects were a bit more subtle and sort of took place over time. Some were very sharp, with lockdowns, etc. But there's a variety of other reasons, changes in the stock market, changes in weather patterns, changes in different, it could be even geopolitical things going on, but there's a lot of reasons your data might shift. So the key is that time-based idea, and how are you going to take something like accuracy as a point measure and turn that into something to check the trend of. So do you want to take your accuracy through time and plot a trend line, and if it's going down, do something, or if it's staying level or going up, it'll be odd if it was going up too high. So you need monitor for things like that as well. But you really have to think, what do I do? Do I do a 10-day rolling average? Do I do a few week rolling average? Do I calculate as many rolling averages as possible and work out some way of looking at that? So it's a good question, Prince. Long answer again, but I think all of the classic metrics you use for ML models you can use, but you have to transition that to thinking in a monitoring mindset, which is a bit different.
I think we are at the halfway mark now. It might be good to conduct a giveaway. Let me just share my screen. I'll just share the specific tab here. If you can see it, just let me know. Can you see the tab? Yeah.
Yep.
So there are 6 people who've entered the draw so far, and I'll just begin the first raffle. These are the 6 people who've entered it so far. If you still haven't entered it, please comment #packed in the comments. And Orge, congratulations, you're one of our first winners. If you can just drop me a message on LinkedIn, that would be helpful, and I'll get the book organized for you. Congratulations, Orge. Anyone else who hasn't commented yet, there is a ticker going at the bottom where my finger is. Just have a read through this, and that's how you can enter in the raffle. So congratulations once again. Okay, just drop me a message on LinkedIn and I'll organize the ebook for you. Let's move on to the next question. Naga on LinkedIn inquires, what are the MLOps frameworks that you recommend?
Good question, Naga. So in the book, I talk a lot about tools to help you do different pipelining, which I would call sort of your framework. So a big one I talk about is ZenML, which I think is really good. It's an open source first project that is really all about helping you build pipelines up from simple Python logic. So sort of mentioned before, I think in one of the other questions, that it's really designed just with some decorators and some thinking about how you stage the different elements of your pipeline. You can build quite complex pipelines. They have lots of really good ways of working with different stacks as well, they call it. So basically integrating with other technologies, and it's sort of abstracted away your compute layer, and a lot of the other important aspects is taken away. So you just need a certain decorator, certain pieces of syntax and logic, and you can connect to a variety of different compute engines across multiple clouds. So I really like ZenML for that. They also provide a lot of good examples of, monitoring and other things. There are similar solutions like that, like Selden and others that I'm less familiar with. I play with, in the book, Alibi Detect from Selden, but not so much the Selden platform. But ZenML I really like. Another one that I'm very keen on is Kubeflow. Similar idea to ZenML, but now it's much more of a Kubernetes native solution. So it's still about providing an abstraction for you to use a certain compute layer, in this case, Kubernetes, but trying to do it with very simplified sort of logic that can wrap your existing Python ML code. So I talk a lot in the book about using Kubeflow for some examples and building it up and showing you how the dashboard works. And I like that because, again, it's open source, but it provides you a lot of stuff out of the box, just like ZenML. So you get a dashboard, you get some monitoring, you get to schedule your runs and orchestrate them a little bit, and you get that integration with something that for data scientists and ML people is a bit more difficult for them to get started. So Kubernetes often scares people, I think, because there is a steep learning curve. But something like Kubeflow really helps you ease into that. And I sort of like that. So I think I like those sort of frameworks that really help you build those pipelines. And then any of the variety of open source stuff that's out there, there's so many now. There's so many great packages. There's so many great tools and concepts available. There's great open source and paid for vendors. But I think those two in particular stand out for me as ones I really exposed a lot about in the book that I really liked. They're good to get started with, good to play with, but can be quite powerful and take you all the way up to production workloads.
Thanks for that, Andy. So Krishna from earlier also inquires, like, why do R and Python give different accuracy? Do engineers tend to use both languages and choose the one with better accuracy? Is that what happens?
I think Krishna's obviously working on a project where accuracy is the key thing. So let's think about him. Maybe change the metric, Krishna, and things will get easier. R and Python. So if you've got a specific example where they're giving different accuracy for your ML problem, same data, etc. This is a classic thing where the algorithmic details might be the same, but the implementation is slightly different. And sometimes it could just be as simple as in the core code, there's a number that gets floored or an average is taken at different precisions, and that just feeds through and gives a different answer. Could also be that maybe in each case, if you're using something like random forest, etc., or something where there's some setting of a seed because it's a random, there's a random process involved. It could just be that you're sort of the random numbers you're selecting are a bit different, or you're starting from a different seed, maybe using a different sampling engine. In general, though, they should be within tolerance. If you use algorithms and settings and you make all that as consistent as possible across different solutions, they should be relatively close. They can be different, but they should be relatively close. So I think the stochastic nature of some algorithms allows for some variability, but it shouldn't be drastically different. You shouldn't get 40% accuracy with one, 90% with another. That tells you something's a bit different in each case. To your second question, do engineers use both languages? So without offending anyone, I don't know many engineers in the ML engineering space who use R. There are some who use sort of R Shiny and other things, maybe as a front end, but R to me, just because of its history and it's what it's really good at, is great for exploration and building models and building explanatory models and maybe forecasting models, etc. I don't think it's so great at going into production with. And the reason for that really is because it was not built to do that job. It's very much designed to make it as easy as possible to build sophisticated or apply sophisticated algorithms across statistics and machine learning. That's where it came from. It came from the academic sciences, it came from psychology, it came from statistics, etc. So that's kind of where it's strongest. Python, on the other hand, was originally built as a sort of glue language for DevOps and then morphed into this data lingua franca I mentioned, this sort of language we all speak. And Python really just is good at, or it can be made to be good at, everything almost. So it can glue between different systems. You can use it to sort of orchestrate different things. You can use it to trigger and script, because it was originally mainly a scripting language. But you can also now build these very powerful ML pipelines. So I mentioned before there's other languages out there to the previous question, but I think for me, if you want to get into the engineering side of ML, focusing on the Python is a really good way to go. There will be other languages that come through in the future, as I mentioned before, but definitely sticking with the Python, I think it's just going to make your life a lot easier. It was just built to do that.
Perfect. Andy, while we are waiting for more questions to come in, there are a few more questions that I have.
Mm-hmm.
And let's start with, what future trends do you anticipate in machine learning engineering?
Yep, great question. So obviously, whenever anyone asks about the future, the first thing that comes to mind is generative AI, large language models, and all of foundation models and all of the related pieces. So I think the main challenge for our industry, our area, over the next while, the next few years at least, is to go through the same cycle we did with more classic ML algorithms, which was, there was a statistic a few years ago that 97% of ML projects failed because they couldn't get to production. This was a few years ago. I think through the advent of ML engineering and MLOps, we sort of flipped that round. And I think that was always my ambition, flip it round and most get into production, or at least a good proportion compared to what we had before. I think with the generative AI wave, we're going to start again almost, because we're finding our feet as an industry. We're trying to develop the best practice. We're trying to understand what tools and capabilities are out there. And also things are moving so fast, it's really hard to keep up. So there'll be a lot of kind of stop-starts. There'll be a lot of projects that have been built. I've already seen lots of startups and things where, you know, the solution is basically a skin on top of OpenAI, and then Google or Microsoft, etc., come out and basically say, we've integrated that with all of our Office products. So now, you know, we've not just killed this startup, but we've killed 5 other startups. So I think all of that means it's a very volatile space to be in. Yeah. And there's a lot of learning to do. So the real trend over the next while is going to be understanding how to operationalize LLMs, how to monitor LLMs, and how to use the right infrastructure and apply them in the right use cases. Because just now they're the hammer looking for a nail. Everyone's looking for the nail to hit with the Gen AI hammer. But not all problems will benefit from a large language model solution. Some might benefit more from classic time series, or they might benefit more from more traditional clustering, or a combination of approaches. So it'll be about that as well. And that's one of the reasons, actually, I've started thinking a lot about LLMOps. So for anyone who's not heard this is this new term of basically taking MLOps, but applying it to large language models, but then foundation models more generally, in which case it's sometimes called FMOps. There's lots of acronyms now. But I'm actually going to start writing an LLM ops book with a co-author with Pact. That's going to be the next sort of title that I work on. So I'm really excited about that. We're going to start working that this year, and hopefully release it earlier next year or mid next year. So that's really exciting. So there's going to be a book all about LLM ops, because I think it's such a huge topic and it's very complex. So I think setting that good practice is going to be a big part of the future.
Yeah, I agree with that. And yeah, we're all excited about the LLMOps books as well, Andy. There is a question from Abhishek saying, does MLOps offer any valuable practice that could be applied to data engineering? Are there any matching synergies between the two? I think the latter part you answered it earlier, but yeah, why not?
Yeah, I can recap. Hi, Abhishek. Abhishek works with me in NatWest. How you doing? He's one of our hotshot data engineers. To the first question, Abhishek, it's a really good one. I absolutely think yes. I now often talk as well in working at events about XOps. So kind of where X could be ML, data, DevSec, MLSec, LLM, FM, put whatever in there. But the key thing is the ops piece. The key thing is the ops. And the thing that draws them all together is that when you operationalize the solution, you have to monitor, you have to test, you have to deploy, you have to have a deployment strategy where you roll back or whatever, blue-green deployments, etc. So there's all these practices that are absolutely the same, whether you're building a web app on Kubernetes or whether you're building a data engineering pipeline that runs on Snowflake, or whether you're building an ML engineering pipeline that runs on ZenML hosted in a cloud. So I think just those practices it's just basically good software engineering practices where it's about, building really robust software, testing it to death. What is your deployment strategy? What's your monitoring strategy? So those kind of buckets of activities are all very similar across the different ops and engineering strands. What we were mentioning earlier, Abhishek, you might have missed, one of the first questions was about the synergy or differences between data engineering, ML engineering, MLOps engineering, etc. I think where they're different is for data engineering, your metrics will be different that you want to monitor. So you really have a lot about the robustness and integrity of the data. You'll have a lot about, monitoring the uptime and ensuring that your pipelines have good fallbacks if they break, etc. You will be less concerned about drifts in your data. You might be, but I think you'll be less concerned about those more statistical measures of the data. You'll be concerned more about, has it maintained its integrity through the pipeline? Have I maintained the right number of different values in certain fields, etc.? Have I brought through things and maintained the data contracts that I wanted to, and can others access that data? So you'll be testing those sort of things. Whereas in the ML engineering space, you maybe have a little bit of those, but more focused on, like we were discussing earlier, what's the accuracy, recall, or precision, or root mean squared error of my algorithm? Has it performed as expected? Has the solution actually set that target to the right place? What's the latency of that? That's a good one for data engineers as well, actually. Am I returning things in the right time? If it's event driven, am I getting the low level latencies I want? If it's batch, am I making sure that things run in the right amount of time and at the right time? And then that relates to scheduling and orchestration, which is often you can use the same tools now. So Apache Airflow, which we talk about a lot in the book, can be used for data engineering, can be used for just classic Python processes, can be used for ML. So there's a lot of synergies there as well. Good questions.
Perfect. So while you're waiting for more questions to come, Andy, I would like for you to answer something about the book. I'll share the book on the screen just so that people are aware of what we're talking about. So this is the book, and I will remove this comment. So what is new in this book? What is new in this edition? This is the second edition of it.
Yep, no, really good question. So the first book was very much about, getting to the core of things and starting to introduce people to the main concepts. And I did that through a certain suite of tools, but I sort of took a breadth approach in the first book. It was a bit short. It was a good bit shorter than this one. Maybe 250, 260 pages of solid content. And that was more about, here are all the different areas of ML engineering and ML ops, and here are some examples within them and how to think about it practically. This edition have sort of supercharged all of those areas and went into a lot more depth. So there's a lot more about every tool I discuss. There's a lot more about, how to work as an ML engineer in wider projects. So we talk about different project methodologies like CRISP-DM, etc. A lot of that stuff wasn't there before. We talk a lot more about, just all the classic pieces, monitoring, model, validation, all of these, but it's just a lot more depth. The other thing that was really exciting about this edition was we also added a lot of new tools that I sort of didn't have to hand, or I didn't have the capacity, etc., to put in the first book. So the ones I mentioned earlier, there's a lot of work on ZenML and Kubeflow as pipelining tools, a lot more on Airflow, a lot more complex examples from Airflow. So there's a lot kind of more depth and newer examples there. There's a whole chapter on deep learning, generative AI, and LLM ops, which was a kind of an addition based on obviously the excitement that's happening now, and that's a good precursor into that LLM ops book I mentioned that I'll be writing. But that whole chapter now is focused, whereas before I'd sort of had some examples of deep learning and said, look, a lot of stuff is quite translatable, but here I go more into the nuts and bolts and start building some deep learning models and talk about how it's different. And then for Gen AI and LLM ops, start thinking, what are these new areas? Also revamped the end examples. So before we had 2 examples at the end, the last 2 chapters of the book, I totally changed one of them to make it Kubernetes based because I thought that was more modern and more relevant to what was now in the book. So definitely brought that right up to date. Totally different example, or a very severely tweaked example, all about Kubernetes deployment of a system. And I talk about blue-green deployments and all these exciting things. And then the other example, we just added a lot more depth to it and fleshed it out a lot more. So it's really a different book. Has a lot of the heart and soul of the first one, but I think it's just more of everything and more in depth, which I think it was really fun to write, and it was the book I sort of really wanted to write. So I'm very, very proud of this one. Actually, I'm very, very proud of it. So it's been great to see it come to fruition, and then the feedback online and from really great people in the community, has been great. We've had a lot of great people share it. Some of whom I've been really surprised because I'm like, oh, you're a superstar with like 80 or 100,000 followers. That's great. So it's been good, but that's how it's different, really.
Right. So Andy, who would you say when you were writing the book, who was the target audience that you had in mind? And if someone is deciding at this point in time, if they're watching it right now live or later on the recorded version, what would be the prerequisites that they need to have before they even think of buying the book?
Yep, great question. So it's definitely not an introduction to ML book. Santiago Valarmo shared that he sort of said the same thing when people were asking him. He said, look, I recommend this book for my courses, but it's not a ABC first stage into ML. Because I just think there's so much good content on that out there. It just doesn't make sense to add. It's also not kind of where my strengths are. So this book sort of assumes you've had exposure to the concept of ML in some sense. So you've maybe actually worked as a data scientist, you are a data scientist, or you've at least done some Coursera or edX or some sort of courses on, what's the basics of machine learning models? How do I build my own ML models, use data, train a model, hyperparameter tune, and do train, test, validate splits? So I kind of assume that is base. I assume as well you've been exposed and used Python in some sense. So I don't expect you're a Python expert. I don't expect that you're like out of this world on it. I do expect sort of maybe strong beginner to intermediate knowledge. I take you through a lot of stuff. I do a bit of a recap, I think, in chapter 4, where I talk about packaging up your own solutions. I do a big recap of some of the core concepts of Python, I think, to bring people to the same place. But I do sort of assume you've seen some of that before. And then from that, it's anyone's game. So it's really ideal for budding ML engineers, working ML engineers, data scientists, data engineers. It will be useful for software engineers working in Python, I think, who want to learn more about ML engineering. So I think it speaks to that demographic as well. Then again, I've had a few kind of people who I know who are non-technical in my network, who are more, senior leaders or project managers, etc. And they've bought it and they really like it because it makes things a bit more real to them. What do we mean when we say all this? So there's that as well. But that's the core sort of demographic we're going after, I think.
Perfect. Thanks a lot, Andy, for clarifying that. Before we wrap it up, I think we'll just do a final giveaway. I'll share my screen again, and here is the giveaway tool. Okay, so Jorge was the last winner, and we're doing a second one. Can you all see my screen? Can you see my screen, Andy?
Yep.
Okay, so we've got a total of 12 entries I can see over here, and I'm just clicking on draw. It's totally random. I've got no say in this. And let's see who our second winner is. Vinay Banka on YouTube. Congratulations, Vinay. If you can get in touch with me on LinkedIn, you can just look me up, or you can look up Andy. You can get in touch with any of us on LinkedIn, and we'll get your ebook organized for you. Congratulations, Vinay and Jorge, both of y'all. Andy, before we wrap up, firstly, thank you everyone for all your valuable questions. I hope y'all are happy with the answers that Andy gave. Is there any closing comments that you would like to add? Possibly,
for me, yeah. So I think one I went to, well, I'll share you a little sort of story and a little thought. So I went to a talk recently by a Silicon Valley billionaire who was in my hometown. He was in here in Scotland giving a talk to some budding entrepreneurs, and I was invited along just because I'm in the sort of Scottish business community. And he started by saying that the world needs entrepreneurs to solve problems. And I thought that was so true. But what I think we really need is we need more ML engineers. We need more people building the solutions of the 21st century that take the huge volumes of data we have and turning it into value defined in whatever way you want, whether that's, shareholder value, solving customers' problems, but also solving problems in the third sector and charities, helping solve problems with the climate. We need more people working in the space of data who understand how to bring great ideas to fruition and build them into products. So I think there's a real sort of call to arms here, or a call out for the community. I need you all to go out and spread the word, basically, that we need more people doing this. That's why I wanted to write this book. It's a little contribution towards that. But all of you here listening, all of your teams, all of your network, we are going to be the people powering the future, really. Sundar Pichai, the CEO of Google, always talks about how AI is the new electricity, and we're the sort of engineers who can work with that electricity and build things with it. So that's the real thought I wanted to finish on. This is the most exciting time to work in this space. We are literally building the future. So I think we need to just grasp that and do amazing things with it, and go and spread that word and get more people into the field.
Thank you so much, Andy. It's an amazing note to end on. Thank you so much, everyone, for your time. And I hope you enjoyed the session as much as both of us did. Did you, Andy? Okay, perfect.
I did. No, it was great. No, thank you, everyone, for your questions. They were all great questions. Thank you. And well done to the winners. It's really good.
Perfect. Hope to see you all on Discord. And we can have more fun with Andy and get to learn from him more over there. Thank you, everyone. Have a great day.